This is part 3 of section 10.2, Series and Convergence. So we are going to come up with our first test for convergence. And actually this is really a test for divergence because it doesn't tell us more than that. So this is called the nth term test for divergence. So what we know is that if a series converges, the limit of its nth term must be 0. So in other words, if the summation of a sub n from n equals 1 to infinity converges, then the limit as n approaches infinity of a sub n equals 0. That just goes without saying. So if you know that the series converges, that means that there has to be a sum. So that means if you look at each term of the sequence, they have to be getting smaller and smaller. So eventually you're adding 0 or nothing to that. So you do have a definite sum, a real sum. So the contrapositive gives a useful test, and this is the important point here, for divergence. That is to say that if the limit does not converge to 0, the series must diverge. And we're going to use that in the future for other tests. So if the limit as n approaches infinity of a sub n does not equal 0, then we can say for sure that the series a sub n, the summation of which from n equals 1 to infinity, diverges. Now, the problem is, though, that doesn't automatically mean that the series converges. Most times, if you know it doesn't diverge, you can't necessarily say that it converges by this test. And I know that seems a little off-kilter, but the idea is you can definitely tell that if it doesn't, the limit doesn't go to 0, then it definitely diverges. But it doesn't automatically mean that it converges. That's the problem with a contrapositive statement. Okay, so let's look at a couple of examples. So example 7 says, determine whether each series converges, diverges, or not be able to tell. So in part A, we have this series, the summation from n equals 1 to infinity of n squared over 5n squared plus 4. So what we want to do is take the limit of this. So we are going to take the limit as n approaches infinity of n squared over 5. I don't know why it's doing that. That's weird. Try that again. N squared over 5 n squared plus 4. So if we look at this, we can see the limit is going to be 1/5. So with that, then we can see right away that 1/5 is not equal to 0. So we can say that this series diverges. That's pretty definitive. Okay, part B and C is a completely different story. So for part B, if we start by taking the limit as n approaches infinity of n over n cubed plus 1, we are going to get 0. But it may or may not converge. We know it doesn't diverge. And I know that doesn't seem right, but the next section will clear a lot of this up. So finally, we have one of the most basic series, which is 1 over n. So when we look at that, what we're going to see is that the limit as n approaches infinity of 1 over n is going to equal 0. But in this case, we cannot say that it converges. Here's why. This is a special series. If we look at all the terms of this series, we write them out. We have 1 plus a half plus a third plus a fourth. So is the limit of this, is this going to equal some specific number? This is not converging. It's going to keep growing. So this series actually diverges. And this is going to be the launching point for the next section. So keep that in mind. And then finally, we have a couple formulas, and these formulas and term values from the nth partial sum. So in other words, what we're going to do is work backwards. If we know what the nth partial sum is there a way to find a sub n? So this is a pretty common problem, and there's a little trick to it. So we're going to talk about that. So if I were to write these out, I just want to remember, what does S sub n mean? So S sub n means that you take all the terms and you add them up to the nth term. So you have one before the nth term, the n minus 1 term, and then the nth term. So if we think about it, if we want a sub n, what we can do is take S sub n and subtract all of these terms from them. Well, what do those terms represent as a group? What they represent is the sum of the n minus 1 terms. So we can write a sub n as S sub n minus S sub n minus 1. And that will give us a formula for the a sub nth term. So let's go ahead and do that. So a sub n is going to equal, and we already have a formula for the S sub n term, n plus 2 over n plus 5, and then we're going to subtract from that n minus 1 plus 2 over n minus 1 plus 5. So simplifying this, we have n plus 2 over n plus 5, and we're going to subtract from that n plus 1 over n plus 4. So now what we have to do is we have to find a common denominator and simplify this. We get n plus 2 times n plus 4 over n plus 5 times n plus 4. And then minus, and then we have our n plus 1. We're going to multiply that times n plus 5 over n plus 5 times n plus 4. So simplifying, we have an n squared plus 6n plus 8 over our common denominator, n plus 5 times n plus 4. And we're going to subtract from that. I'm just going to put it in one big fraction. We're going to subtract from that n squared plus 6n plus 5. So when we do that, we get that a sub n is going to equal, these are going to cancel, the 6n's will cancel, we get 3 over n plus 5 times n plus 4. So we have created the rule for a sub n. So we're going to do the same thing for the final problem of this section. So we have our S sub n for this series is n squared plus 2 over n plus 1. And this time, instead of wanting a general term, we want specifically a sub 6. So we're going to get that by taking the 6th partial sum and subtracting from it the 5th partial sum. So we have specific numbers to substitute for n, so we are going to get an actual value for a sub 6. So using that idea that we did in the last one, I'm going to substitute in 6. So I have 6 squared plus 2 over 6 plus 1. And from that, I'm going to subtract 5 squared plus 2 over 5 plus 1. So this is going to give me 38 over 7 minus 27 over 6. Creating a common denominator, I have 228 over 42 minus 199 over 42. So combining these, I get, oh, I think I made a mistake there, 27 times 7. Let me do that real quick. I think I have the wrong number there. It's 49. 189. There we go. Sorry about that. When we subtract these then, we are going to get 39 over 42, which is equal to 13 over 14. So that's my a sub 6. And that is going to include our discussion on series and convergence. As I said earlier in some of the other videos, we are going to use this as a launching pad in subsequent videos. If you have any questions, please feel free to ask them in class.